so cold.
Look at the thermostat. I bet it's set at like 80 to 85.
What's going on there?
I'm enjoying it right now.
Well, the building is either usually all air or all heat. And so I think they haven't kicked it over to heat yet. And we have these windows, so like if it's cold outside,
Yeah.
the heat gets sucked out.
Yesterday.
Happy birthday.
Thank you. It's great. We just went to Chicago for the weekend. We did like a Boston party. It was pretty dope.
I saw a post with the Mario Man.
Yeah, that's good. I love my mom's actually. Yeah.
How's your mom doing?
She's doing good. Like, but she's still going to the gym 6 days a week. Like, she's getting back to it.
Grace.
No, yeah.
Lincoln is born.
Oh my god. Why is it weird? Yeah, it's not like
Okay, if you guys did not turn in number 50, that book assignment in the Google Classroom, your last chance to get full points on it would be right now, so you might need to double check that. And I need you to get out number 51 from your binder. I gave that to you last class, we just didn't have time to get to it, so, but you already have it. Three, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Okay, no more assignment number 50s, that short book assignment. Okay, then the next topics we need to talk about are from handout 51, which will be extreme value theorem and mean value theorem.
Do you look at lost in binder or something? I think I'm gonna look my binder.
I think there's a binder in the back corner on the counter. I don't know if it's yours. So, as I had mentioned before we started class last time, this unit has really 4 big ideas. First derivative test, which you did last time. Second derivative test, which we'll talk about next time. And extreme value theorem and mean value theorem. So, we're going to introduce 2 of those today. So this is similar to intermediate value theorem, if you remember that from the beginning of the year. Intermediate value theorem helps you know about numbers that are in the middle. And these 2 just serve a different purpose. So let's see what we got. Okay, first one we're going to look at is extreme value theorem, or EVT. And what it is good for is finding the absolute min and max. So last time we talked about first derivative test helps you find relative maxes or local maxes and relative mins or local mins. But those are just either the biggest point or smallest point in a small set of data. Extreme value theorem, also known as global sometimes, is if you're wanting to find the absolute biggest or smallest value. So over the whole graph. So what the extreme value theorem says is that your absolute biggest or smallest values will occur at either relative extrema, or at endpoints. So I tried to find a picture on the internet there so we can get a little bit of a variety of those. So if I have the full graph in front of me, of course we can just look at it and see where the absolute max is. The absolute max is right here. It's the biggest y value on the graph. And the absolute min, smallest y value on the graph. And notice it either occurs at a local max, local min, or at an endpoint. Okay? So filling in a couple blanks here, just to put down what I just verbally said. We have relative maxes at x equals b and at x equals d. We also have relative mins at x equals c. And then it talks about at x equals e. This is not a local min, because for a local min it has to switch from decreasing to increasing. So if it doesn't exist after that, this can't be a local min. Okay, so again, extreme value theorem just says that assuming your graph's not jumping around, it's continuous, there has to be a biggest y value and a smallest y value, and it's going to either occur at critical numbers, because critical numbers are where we find the extrema, or at the endpoints. Okay, so let's look at a few examples to try to apply this. All right, first off, this one says find the critical points between 0 and 3. So this is what we did last time. Critical numbers come from when the first derivative is 0 or undefined. So you've got to take the first derivative. If there's any x's in your denominator, you need to solve for that to know where it's undefined. Otherwise, you've got to do algebra to figure out where it's 0. Those are critical numbers. Now, technically, to be critical points, these points have to exist on the function. So if I plug in a 0 in here, there's no problem. It's going to be on the graph. If I plug in a -2 here, it exists. So it's no problem as well. So these critical numbers are also critical points. Okay, if we want to, okay, so here's the first part. Find the critical numbers. I guess we should label those. Thank you. Those are critical numbers. Then identify the relative and absolute extremas. Grace, do you have a pass? Do you have a pass for being late? You got almost absent. Okay, so if I want to find the relative extrema, that is still something we did last time. We could do, well, actually let's skip this part because we've done this last time. Relative extrema, we could do the little number chart, say 0 is a critical number, -2 is a critical number, and then we can test around that to know where it's going up or down, so we know where relative maxes and relative mins are. The new part of this, the extreme value theorem, is to find this part, the absolute extrema. So I want to know what's the biggest y value on this function and the smallest y value. So we have to make something called a candidate's test. Where does it say that? you don't need to know the name of the candidates test, but a candidates test is basically just a table. And this is going to be really important for some of our FRQs as we move throughout the year. Anytime you're asked to find the biggest value or the smallest value, that is extreme value theorem. And extreme value theorem says you need to test all the critical numbers, which we talked about how to find last time, but you also need to try out the endpoints. So this graph was 0 to 3. Okay, we only care about 0 to 3 here. The biggest and smallest values are going to come at one of those 3 points. I say 3 because 0 is duplicated. Now, I know x equals 0 is likely to be the absolute max or absolute min. How do I find the y value though?
Plug it in.
Okay, plug it into what though? Alright, if you want a point, you should be plugging into the original function. Plug into the derivative if you want to know the slope or whether it's increasing, decreasing. So if I plug in 0 into this, I get 0. So I know 0, 0 is a point on the graph. That's a possible absolute max or absolute min. I could plug in -2 into this. And I definitely could do that by hand, but just for time's sake, this comes out to be 4/3. Or it might show up in an endpoint, which would be 0 or 3. Those are the endpoints just because that's what the question said. But I'm not testing 0 again. I already did 0. 0, 0 is a point. If you plug in 3, you get 18. So as we move throughout the year, when we see FRQs that ask you to find absolute max or absolute min, this is the work that they want you to show. That stuff there that's highlighted, this is called a candidates test. I've tested the critical numbers, I've tested the endpoints. Now I can see the smallest of those values. The absolute min is at x equals 0. And right here, I can see the biggest of those values. The absolute max occurs at x equals 3, but the absolute max is 18. So, extreme value theorem is trying to do us a favor. We're not having to figure out what that graph looks like. We're not having to test a million points. It tells you that if you need to know the absolute min and or max, it's going to occur at a critical number or an endpoint. So you find the critical numbers, find their y values, find the endpoints, find their y values, and then just comparing the y values, you can see the smallest one and you can see the biggest one. That's what extreme value theorem says. Okay, anything that jumps out at you about number 1 before we look at one more of these? Okay, question 2. Determine all extrema, and again, just for now, we talked about relative extrema last time, so we're going to say global or absolute or extreme, extrema, whatever you want to call them. So that's it. That's going to be EVT, and EVT says your absolute smallest and biggest values are going to occur either at critical numbers or at endpoints. So the endpoints in this question are -2 to 3. And I said this a minute ago, but again, I don't know if I pointed this out enough. This visual tries to show you that the absolute max can occur at a relative max, but a relative max is not necessarily the absolute max. This y value is bigger than this y value. Relative min might be the absolute min, but it could also be a endpoint. So we've got to test those, all the critical numbers and the endpoints. Okay, define the critical numbers. That's what we talked about last time. That's where the first derivative is going to be 0 or undefined. So the algebra behind that, of course, can vary in difficulty. This one's power rule a bunch of times, maybe factor out of 3, factor as an x plus 1 times an x plus 1. And so it looks like the only critical numbers, this doesn't give me one, is -1. So what I need you to try to appreciate is that without doing this, without the extreme value theorem, you basically just have to spin long enough to figure out what this graph looks like, or you just have to test hundreds of points until you're confident what the biggest y values are. Extreme value theorem, yeah, this took me a minute, but it narrows it down to 3 spots. These are the 3 times where we might have the absolute max or min. So if I want to know what the y value is at x equals -1, just going to plug -1 into the function because I'm interested in a point here. I want to know what is the y value at -1. Don't plug it into the derivative. The derivative would tell you the slope at that time, and that's just not what we're interested in here. Okay, and then once you have this data in front of you, what would you say the absolute min is? I'm sorry? Correct? So the absolute min is -1, and it occurs when x is -2. Sometimes you need to know that. But the absolute min is -1. And then the absolute max would be what? 64. Max is 64, and sometimes you need to know when it occurs. It occurs when x is 3, but the absolute max is 64. So if you wanted to take the time to graph this in your calculator, and you'd have to zoom out a bit, but the very smallest y value is -1, the very biggest y value is 64. Extreme value theorem just says that absolute min and max occur at either critical numbers or endpoints. Those are the only values you have to test. And this table, just this highlighted part, this is called a candidates test, and this is by far the easiest way to get those justification points on an FRQ. You don't have to say why, like you don't have to label that these are the critical numbers or these are the endpoints, just the highlighted part. That would be your justification. Okay, let's move on to the other one. The other one we're going to talk about today is mean value theorem. I'm going to have you practice some of these in Khan Academy once we're done here. So this is the last of the 3 big theorems. We had intermediate value theorem in Unit 1, extreme value theorem, and then the last that we need in calculus is called mean value theorem. So when we hear the word, these words should give you a hint. The last one, extreme, that's the biggest and smallest. But mean, what does mean mean to you? Average. So not the mean to you like not nice, but it's like an average. So what the mean value theorem says is as long as your graph is not jumping around, it's continuous, and as long as it's differentiable, meaning there's no sharp turns, there has to be at least one time, at least once, where the instantaneous rate of change is derivative, is equal to the average rate of change. and average rate of change is the slope formula. So I tried to draw a picture over here to help you visualize what this is saying. The second half of this, the average rate of change. If I ask you what's the average rate of change from A to B down here, you would take the starting value at A, the ending value at B, you would calculate how much time that takes, and this is the slope formula. This is the average rate of change. This is what we're computing over here. What mean value theorem says is that if this function is continuous and differentiable over that interval, there has to be one time where the derivative is the same. You see how these two are parallel? They have the same slope. So the instantaneous rate of change, there's one time where it equals the average rate of change. And we usually call that time c. So maybe to just throw out one more example, because it's not a hard concept, but it is a little hard to wrap your head around what we're trying to do here. Okay, let's do this one. So the average rate of change from A to B might be 0. And because from A to B is continuous and differentiable, there's no cusp, which makes it differentiable. There's no holes or asymptotes, which makes it continuous. There has to be at least one other time where it's equal to that. If the average rate of change is 0, there's at least one time where the instantaneous rate of change is 0. And the time that that occurs, we usually call that x value c. Okay, so for this one, they want us to actually find c. So they gave us a function, tell us to look from -2 to 2, and we need to find the value of c that satisfies the mean value theorem. So on one side of the mean value theorem, we need to do the derivative. On one side of the mean value theorem, we need to do the slope formula for average. Instantaneous is equal to average. So this would be f of 2 minus f of -2 over 2 minus -2. And I can do those by hand, but for time purposes, let me just throw them in the calculator real fast. This would be -6 minus 2 over 4. So -8 over 4 would be -2. See if we can subtract this over. Divide both sides by a negative maybe. Divide both sides by 6. And maybe take the square root. And when I take the square root of x squared, I get x. When I take the square root of 4/3, what do we get?
2/3.
Close. You can take the square root of the numerator to get 2, but then you have to take the square root of the denominator also if you're going to do that. I'm going to leave it 4/3, or the square root of 4/3, but there's still one other part to that.
Plus and minus.
You take the square root of both sides, we need a plus or minus. So, mean value theorem only guaranteed that there would be one time that this happens, but it looks like there's 2 times in this interval that that happens. There's 2 x values where this happens. So let me see if I can graph this so we can see what we just found. Okay. Does that look like the function there? I'm trying to switch back and forth. Okay, and I really only care about -2 to 2, so I'm going to change that part of my graph to only look at that. Okay, so on the right side of our equation, we did the average rate of change, so that's going to be this. How much change you just have to do at a steady pace, and what did we say that came out to be? That was over here, -2. So the slope from here to here is -2. If you go down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, that's this. Let's see. Okay, let's try this. Okay, so the average rate of change, the right side of our equation was this. The average rate of change was -2. We got that from the slope formula. On the left side of the equation, we did the instantaneous rate of change, which was derivative, and then we solved it for x, or for c if you want to call it c, and we got two numbers that made that happen. What were those? Square root of 4/3 or something? So, I do have that. The square root of 4/3 is about 1.2. So when x is about 1.2, do you see how the slopes are the same? The average rate of change is equal to the average rate of change is equal to the instantaneous rate of change. The other answer we got was negative, so that would be -1.5 right about here. Negative square root of 4/3. So there was 2 times where the instantaneous rate of change equaled the average rate of change. Instantaneous rate of change came from the derivative. The average rate of change comes from the slope formula. Okay, and then of course for mean value theorem to work, it's got to be continuous. So the reason why that's important, if it's not continuous, your graph is going to be jumping around. So this would be, you can word this however you want to, but this assures us that the graph does not jump around. If the graph jumps around, then the average rate of change may not equal the instantaneous rate of change. And it's important that it's differentiable. You should notice the slight little difference here. You might need to look back at this when we get to the Khan Academies in a minute. But continuous has to be over the closed interval, differentiable over the open interval. And this assures us that there is no sharp turns. If it had sharp turns or jumps in the graph or values that don't exist in the graph, mean value theorem may not hold up. Okay, the last one is, and this one you don't really need to know the name of it. I only keep it on here. In fact, I really only want to do one of these because it's a little less important. Rolle's theorem. Rolle's theorem is not a name that you will see on our AP test or any of our tests. It's really just a very specific case of mean value theorem. I still like to show it to you at least once, just because you may hear of Rolle's theorem sometime in the future. But it's exactly the mean value theorem where it says instantaneous rate of change equals average rate of change, but it is specific where the average rate of change happens to be 0. That's the only difference, or it's not even different. It's just a very specific mean value theorem case. So if we do number 3 as an example, find all the numbers C guaranteed by Rolle's theorem for this between 0 and 4. So if we just treat Rolle's theorem as mean value theorem says instantaneous rate of change, which is derivative, is equal to average rate of change, which is slope, and the only thing that makes this called the Rolle's theorem is that the average rate of change in Rolle's theorem always goes to 0. Okay, and then to find this C value that they're talking about, C is the X values that are guaranteed by the mean value theorem. So you finish solving this, add the 4 over, divide by 2, X equals 2, or if you'd rather call it C equals 2. That's the place where the average rate of change equals the instantaneous rate of change. I'm going to graph this one more time because, again, I feel like you can structure this and get a lot of the answers right, but for this to really stick in your head, you really need to visualize what's going on here, what you're trying to find. Okay, here's the function, and in this question we cared about 0 to 4. So I'll change the window settings 0 to 4. Okay, so do you see how the average rate of change is 0 there? That was the right half of our equation. Do you see how there's a time where the instantaneous rate of change is also 0? Well, when we set those two things equal to each other and solve for C, we're finding the X value where that occurs. Do you see how that occurs at X equals 2? So normally you don't have the picture in front of you. That's what we're finding with this work. Instantaneous derivative is equal to average, which is slope formula. Okay, I would like you to try this one question real quick just to see if any of these jump out at you. This is a question about one of these two topics, but it's a table. So read the question, see what you think you need to do, and commit yourself to an answer. We'll see if you're right. Okay, that may not be enough time, but does anyone feel like choice A is correct? The minimum value between 0 and 4 is 2. Okay, A is not true. Why is A not true? Or not necessarily true. It might be true, but we don't know for sure. What do you think?
2 is the maximum.
No, there's a bigger value. 4 and 3 are both bigger than 2.
0.
What about 0?
Oh, no. I just got everything.
You don't necessarily know if the graph goes lower than 2 out of it points in between those numbers.
Right. You only know 5. You've got 5 little snapshots here. You don't know if when x is a half, y is negative 100. You don't know what's going on between these values. You know that there's something between those values because it's continuous. But you can't just assume that the smallest must be 2. You don't know you only know those 5 points, but there's an infinite number of points between those. So that's why you should not assume that the minimum is 2. Same reason, you should not assume that the maximum is 4. The maximum listed one is 4, but I don't know what's going on between 0 and 1, 1 and 2, 2 and 3, and 3 and 4. Maybe between 3 and 4 at like 3.5, maybe it jumps to a y value of 100. I have no way of knowing that. So it's not guaranteed that that's the biggest. It says must be true. Okay, choice C. Is the y value always positive for these values?
There's no way of knowing what goes on between.
Right, it looks like they are, but again, between 0 and 1, we don't know what's going on. There might be some negative values in there. So this isn't guaranteed to be true. And is the derivative negative from 2 to 4? Remember, derivative means slope. So to go from 2 to 3, do you see that it's going down 1? Because it's going 4 to 3. And then from x equals 3 to x equals 4, do you see it's going down 1 again?
Yeah.
Does that mean that the slope is negative all the time between these two? Not necessarily, because at 2.5 it might go up for a second. You don't know what's going on between those values. So that may not be true. Which leaves us to choice E, what sounds a whole lot like the mean value theorem. There's some number C between 0 and 4 where the instantaneous rate of change has to equal 0. Why 0?
Because it ends up on the y value of 2 of both ends.
Right, if you start at a y value of 2 and end at a y value of 2, your slope's going to be 0. So if your average rate of change is 0, your instantaneous rate of change derivative has to be 0 too. This is, notice they didn't say anything about mean value theorem. You don't have to know the name of it, but that's exactly what it is. This was continuous and differentiable the whole way, which guarantees there's some number C where the instantaneous rate of change equals the average rate of change. This question, the average rate of change was 0, because if you do slope formula, you get 0. And I know it's an old question, but I like y'all to see that it is from the AP exam. It was on the BC exam, but some questions end up on AB and BC. So BC students get AB questions too. So I'd like you to see that one, and then I'd like you to read this last one before we move on. And I want you to think about what this is saying and see if you can figure out. Because as far as I know, this is actually used all the time. Could be used against you someday too. So if you have two cop cars that are 1.2 miles apart, and you pass the first one doing 35 miles per hour, and then 1.5 minutes later you pass the second cop car at 30 miles per hour. The speed limit sign was 35 miles per hour. So does this person get a ticket or not?
No.
Why?
Just
The first cop sees you do 35 miles per hour and the second cop sees you do 30 miles per hour.
Obviously, you've slowed down since then.
But they might not have seen you do 45 in the middle,
How do you know you did 45 in the middle?
or like anything. You could have gone faster, could have gone slower in the middle, we don't know.
But we do know.
Do you know?
We can prove this with mean value theorem. Your car, its position in time is continuous. It doesn't just magically jump 10 feet. Your speed can slowly go up or slowly go down. It's not at a sharp turn like a cusp. So the average rate of change, if you're doing this much distance over this much time,
I didn't think it was that.
and I'm going to change this to hours. 1.5 minutes is the same thing as 0.025 hours. That way the units match up. What is this? What am I doing when I take the total distance divided by the amount of time?
Average velocity.
Okay, this is the average speed or velocity. I'm not really concerned about direction here, so speed. This ends up being 48 miles per hour. And mean value theorem says that the average rate of change has to equal what?
The derivative of
Okay, well, cops are not going to use the word derivative.
the slope.
That's this side. I'm talking about the other side.
C.
Cops aren't going to say C.
The mile per hour change. Yeah.
Acceleration.
Yeah.
The instantaneous
I've never heard a cop say that one either.
Rate
I watch
of ch-
cops.
Well, your speed at an instant is your instantaneous rate of speed, or instant rate of change. So, with this simple thing, they can prove you went 48 miles per hour, at least, because that was your average rate of change. Mean value theorem guarantees that at least one time you went 48 miles per hour.
No way they're doing the math though, right there in the patrol car.
This is, I'm doing division. That's the only
That's
division.
too hard though. They're gonna be like, nope.
No, in
but
court, this would absolutely hold up. They could prove you did at least 48 miles per hour.
I'm gonna find a cop and I'm gonna go buy them 5 under. And then I'm gonna speed up to like.
They're not going to know the name mean value theorem, but absolutely, if they're stationed and they know how far apart they are, and they know how long it takes you to get there, they don't have to clock you doing more than 35 miles per hour to know you did more than 35 miles per hour. Y'all see how that's mean value theorem? So, and you don't have to know the name to understand the principle. Okay. So we are at the point where we need to get some more practice under our belt. So you guys need a blank piece of paper. I have 5 different Khan Academy assignments assigned to you. You may want to start with the first derivative test stuff since we did that last time. One is on increasing, decreasing intervals. One is on relative maxes and mins. One is on extreme value theorem, so making the candidates test. One is on mean value theorem justifications, and one is on mean value theorem finding the C value. So, as always, I would like you to get 100 on those. Feel free to start off with whatever ones sound easiest to you.
And we need to do all 5.
You need to do all 5, yes.
Yes, great.
And of course, especially if you're picking out the ones you think are the easiest, you should be able to get 4 in a row correct if you know what you're doing. So I'll give you a few minutes to get a few questions under your belt, and then I'll come around and help out. But this is good practice from our first 2 days in this unit. It has some practice from last time and a little bit of practice from today's notes too. course, you don't have to be working on the same ones that your neighbors are working on, but if you do agree on working on the same ones, you might be able to work together a little bit. You got the right or what?
Yeah, I gotta start with like, I wanna start on the easy one.
How do you increase that?
So yeah, your Windows settings are messed up, so you can either go to Window and change all of it manually, or if you go to Zoom, Zoom 6 can change it by standard, which is probably this one. You know what those little dots are?
I was doing something.
Yeah. If you go to Y equals, you have this stat plot on, that's why it's highlighted. So if you can move the cursor up and hit enter, you can turn it on and off, if you don't want it either. Okay, you will need to do some scratch work, so please put that on a piece of paper that your numbering is 52. And then make sure that you're getting the practice in by answering these questions with the calculus. You can use your calculator and such, but if you're just using your calculator to look at when it's increasing, decreasing, that's not the practice that you need. You need to find the critical numbers, test around the critical numbers so that you can see where it's increasing, decreasing, just like the bookwork from last time.
Do anything for fun for Halloween?
When is Halloween?
Tuesday?
It's already Wednesday.
Yeah, but like this weekend. I don't know.
This weekend's not Tuesday.
Well, yeah, but like you can still like celebrate a couple days earlier, so you don't have to like stay up late Halloween night. I know
No.
you don't stay out. You said you go to bed at like 9 o'clock or 8:30. I don't know. I don't remember. I don't keep track of your sleep schedule.
I also wake up in the morning not tired, usually.
Yeah, but like kind of a freak for that because like nobody does it except for you. Everybody wakes up tired. Right, Luna? You get up and you're like, oh, I want to go back to bed, right?
What'd you say?
Just go to the bathroom.
I thought you said don't involve me. It's close enough. You guys still have close to 45 minutes, and I do want you to have these finished up by next class. The good news for y'all is that this is a B week, so you have all the way until Monday. But of course, you should try to get as much done as you can in class so you don't have any homework or less homework. I guess I am going to ask you to turn in those notes we took today and for homework, but there's no reason you shouldn't have those finished.
I guess on participation.
Have I not done points for notes before in here? Oh, I do occasionally. I would do it all the time if I had time to. It's just...
Didn't we like not answer so many questions?
Well, I don't expect you to have those parts done. Unless I said, I want you to go back and do them later. I'm just checking to see that you participated and have down what we have down.
We substituted into the original version. For like actual beings.
So for this, you would take the derivative of this, right?
That would be the instantaneous rate of change, yep.
And then you'd set that equal to f of -1 minus f of -7 over -1 minus 7.
I did -7. That was -7.
Oh,
Yeah, it's minus whatever it was. So that's gonna change it.
that's right. That's right.
If you have trouble not knowing what your work is supposed to gonna look like for any of these questions, or where you may need to look in your notes, call me over.
So, when I put the square root of this now, does it come plus or minus?
Did you take the square root of both sides?
Not the square, that's square root.
Squaring doesn't do that, but. Again, some of these should be easier than others. I would think the finding C and mean value theorem, those questions, you're gonna have to do more steps for. The justification on mean value theorem, you may not need to write anything down for. But you might need to look back at your notes about how it has to be continuous on the closed interval, differentiable on the open interval. And on the absolute max and min questions, you should be doing the candidates test, like we did with extreme value theorem. You guys got anything I can help with yet?
I have to go back and solve this one, because I have 172, which I think was too big for this one. So, I'm gonna go back and resolve it.
That's just, okay, I don't know. I haven't looked at the whole question, so I don't want to steer you wrong. Do I have anything I can help you start? Anything I can help you start with? You know, anybody?
Not yet.
What do you do when you get 2 values?
You can guarantee more than one. Well, it guarantees there's at least one, but you could have multiple.
So 2 of these could be right.
No, because it says choose one answer, so I would double check your work. Like if this was maybe 1 and 8, I would say ignore 8 because 8's outside of that. But, oh, what it is you wouldn't include the endpoint here because we don't really care what's going on to the right of it. So,
Oh, yeah.
so you're only going to include 1. But I would also sometimes double check your work because it could be that you had a mistake too. Sorry, I forgot this part, but one thing that's a little weird about some of the mean value theorem questions I forgot to tell you. If your bounds are like 0 to 4 and you get 2 solutions for C, maybe like 2 and 4, you should not include the one that's on the ends. So if you got 0 or 4, don't take that as the answer. Take the one that's in between those values. either A, if this is all correct, if this is imaginary, imaginary is not going to show up on a graph, so that would be its way of telling you that there's no solutions. B, to even go from like here to here, you need a calculator, right? Well, if you're going to use a calculator, then you might as well just use a calculator here. Maybe, yeah, just graph it and look for x-intercepts. Like, I'm not saying that you never have to do quadratic formula by hand, but it's pretty rare. So I wouldn't do that unless it was like a no calculator part of a test, and even then I would still be suspicious that was the right method. Still got about 25 minutes, but if you guys are finding questions, please ask as soon as you can. I will give you guys a heads up, and I have no idea when this is, but there is supposed to be a fire drill today, this afternoon. One of the changes this year, though, is they don't tell us exactly when it is, so it's like sometime between 12 and 4. So there's always a chance that it might go off during our class time.
I have a practical question. So,
Okay.
if the case you're doing something like scatter plot, I'm not really sure to get this off that graph.
Sure. So if you go to y equals, see how plot 1 is highlighted?
Yeah.
Okay, so move the cursor up there and enter on it, and that'll turn that part off, so now it won't make the dots. But you still need your zoom to go back to normal. So if you do zoom 6, it'll put it in what you're used to seeing. Why would you bend it? I had the same idea for like 7 years.
Oh my god.
Mine's the same as yours.
There's no. Those are the answers.
You can put it on your shirt if you're ready. What, do you think it looks better?
I think it suits you as a person.
Good answer. Okay. Well, what is this? I know, but what is this one gonna give you? Because that's where that equals 0. So 3x equals 0. You can make an equation, 3x equals 0 when x equals
3x equals 0.
yeah.
When x is 0?
Yeah.
Oh.
So you're saying it right, but you should know why.
Yeah, I did, but I was just making sure because I can't get another question wrong. I can't start over again. So I just gotta check on it.
You're on question number 1.
I know, because I had to start over. I keep getting them.
Mean value theorem. Okay, so instantaneous rate of change would be derivative. Total derivative. Okay, so right here. Oh, this is. Oh, so you haven't started this one. Oh, well, I don't know what the whole question was.
I'll start this one.
Wait, what's the graph of what?
Like how many?
What is that equation of?
You're in the first one.
Big difference.
I didn't think about that.
That one little tick mark changes totally how you word the question. if it's a function, I think you did it like you thought of it.
I thought it was a function, so I did.
But they did the derivative for you, so they were trying to help you with calculus, but graphing and looking at its graph just represents something totally different, so.
So, I had to do that multiple times. It's all the way up there.
Okay.
So, like,
Then you might have had a mistake before that then.
okay,
That would be my guess.
would you like help with that?
Where's your 3x squared plus 24x plus 36? That looks good. Okay, here, sometimes what I do, because there's a lot of places that could go wrong. Alright, you're trying to plug in what? -2 first, right? So do you know how to do the store button?
You skipped it, no, but I mean, I know how to take my answer from like this thing.
From before?
Yeah.
Okay, I still like to do this though, because it's a little bit quicker. If you do -2 and then do store as x, every time I hit x, it's going to know that it's -2. And so I would plug that into the original equation, x cubed plus 12x squared plus 36x should be -32. So you're getting something different. And the nice thing about storing is, even what you were saying is fine too, but then the next number you should plug in is -8. So you could just do, okay, now x is -8, and then I have that part done right away too.
So, maybe is that what it's saying? Oh, wow, okay.
So that means that it's not rising at all. So that whole side should go to 0, it sounds like. It's probably just that you didn't type it in your calculator right when you did it.
I'm gonna say that's what it is.
Do you notice any mistake? These answers on the
They can't be the derivative, but you can do chain rule. Times the 3. Well, what are these numbers? Are these your critical numbers? Yes, you should be putting in numbers around the critical numbers into the derivative. Are you raising your hand or? Use that extra pair of shoes.
How do you know if it's differentiable?
What was it? Okay.
How do you know that the function is differentiable?
Differentiable means that you could be able to plug in any x value you want into the derivative. So, is this the derivative, 2 over pi? Okay, but see how there's no x values there? You can plug in whatever you want to. You're never going to get division by 0. Like, if this was your derivative, x can't be 0. It would be, because it would be undefined. But that's just a number, so you can plug in whatever you want to. So it's definitely differentiable.
Which one are you on?
Basically, letting you start on the next step. You just set this equal to 0, and you solve for that number. And you just do the same thing as you'd always do.
Yeah. The difference is, like, usually you're given a function and you have to take the derivative. They've done that for you. So for you to find critical numbers, you just need to figure out where this is 0 and undefined, which I think you have.
That's what I'll ask for.
Okay. And then test the numbers around it to know when it's increasing and decreasing. And if you do the little number line thing, then it's easy to glance and see.
Wait, you don't have an original function plug against it.
You don't need the original function if you just care about where it's increasing or decreasing. Your critical numbers are just 0 and 2, right? So when you do your line chart, x equals 0 is a critical number, so it might be changing directions there. And x equals 2 is a critical number, so it might be changing directions there. To know whether it's increasing or decreasing here, you should be plugging in the number into the derivative. Because if it's positive, you know it's increasing at that time, and if it's negative, it's decreasing at that time. But you don't need to know the function to do that. At least not that. You're doing okay? Negatives, I agree with that.
Can you finish the justification?
I don't know about the direction of your arrow, because I can't find it. It's a 0 inside of caps, which is what you have. Yeah, it looks like maybe you missed, I think you may have missed this arrow, because it should be decreasing from 0 inside over 2. You're close.
I don't have any Band-Aids.
Do you know who Miss Mathis was?
Do I know that Miss Mathis carries Band-Aids?
I don't know.
I have no idea.
Like,
Sorry.
Is this week a A or B week?
It's a B week.
Oh, nice. No offense.
Why would I be offended?
I don't want to come back in here.
I mean, I just signed you up for prime time.
Well, that's a little unfair.
Is it?
Huh?
I said, is it?
Well, I'll see you next week. I'll see you Monday. If I throw a Halloween party, I'll invite you for sure.
How about Friday during advisory?
Oh, I don't know about that one. I don't know. It's supposed
I
to be a fun
need to-
Friday.
It can be Fun Friday for the people that have their Khan Academies done.
So I got that 0 and 5/2 are the critical numbers,
Okay.
and then I
Is
saw
negative one also?
that. No, that's one that I chose. So that's a 0.
Okay.
No, I finished the first.
Okay, so if I test, here's your derivative. Yes or no?
Yes.
Okay, so if I plug negative 1 in over here, is that positive or negative?
Oh, I played it in 2.
Yeah. You plug into the function if you need to know something about the points, but if you need to know something about the direction or the slope, you need the derivative. Okay guys, we're down to about 5 minutes here. So again, this is a B week, so I won't see you till Monday, so that buys you a little bit more time for the assignment. But if you didn't notice in the homework there, I barely mentioned this verbally, but I do want you to turn in your notes. 51 in the Google Classroom. Occasionally I do give points for doing the notes and participating. Just doesn't happen all the time. So make sure you have that turned in to Google Classroom before Monday and finish up the Khan Academies by Monday. I'd prefer you not to try to do a bunch of them on Sunday night or Monday morning. Maybe just try to do one a day. Would be better.